So as we recommend in the Supplemental cream guidance and also in the USP Chapter 1724, IVRT studies should be conducted under occluded conditions. And because the steady state release kinetics is not expected when the dosage form is undergoing metamorphosis, and most of topical products have volatile components and they undergo metamorphosis. And here we are showing an example of the release profile of a topical gel under unoccluded condition in the orange graph and under occluded condition in the blue graph. And you can see we don't have a good linearity when it was unoccluded, and we getting to plateau after starting at third time points, we getting plateaued in the release rate because probably the formulation is dry, and also the release amount is significantly different compared to the occluded condition. So I just wanted to note the importance of occlusion for the IVRT study. I think we can move to the next topic, and because we are short on time. Okay. So for IVRT validation, one aspect is related to IVRT reproducibility and precision. Sam, I think, did a wonderful job explaining these studies and the required percentage CV that we expect to see for the precision studies. I think one question that we got is if for the altered formulation, we could not have a percentage CV of less than 15%, would that be acceptable? Anyone from FDA wants to comment on that?
I think that, just again, in the interest of time, I think that's understandable. These are bench scale formulations. As long as you can kind of, would you ideally, you want your altered strength release curves to have this, that meet the same linearity criteria, and be as precise, but understood, especially on the higher end. Sometimes that formulation is having some kind of an existential crisis of being at 150%. Understood that these things can happen. I don't think that I think that can be discussed and analyzed and understood. So the more important element is the precision relative to the conditions that the pivotal study is being conducted at. So those, the release rate at the reference strength, those reference conditions, that those should be highly reproducible, precise, and in that you have confidence that you could discriminate differences. When you're creating conditions that are different, there may be some aberrations there where it's not. Most of the time it's fine, but there may be times when it just it isn't.
Okay.
Thoughts on the group?
I think the IVRT method is generally optimized for one certain composition. I think the question probably refers to altered composition, and that's understandable if you don't have, because your method is not optimized for that composition. So you may not get as good a precision as you have for the 100%.
Okay, thank you. We can move to the next bullet point, which is about IVRT sensitivity. I think we covered, and if you can also show the next bullet point, Sam. So IVRT sensitivity is expected to be performed using lower strength and a higher strength, and we recommend the lower strength to be not less than 50% and the higher strength to be not more than 150%. We have some graphical demonstrations in the coming slide that I think we can talk a little bit about the challenges to passing the selectivity of 150%. And we already, I think, discussed the challenges with formulation of higher strength and bench batches versus GMP batches in the previous session. Is there any final point that we want to discuss here regarding challenges to formulate higher strength? And or if you guys think it is well covered, then we can move to the next slide.
Well, hopefully it's clear you do not have to make GMP batches of these
Yeah.
50%, and you do not need to do that. Yeah. So these are going to be bench scale batches.
But I think, Josephine, you would like to clarify what data needs to be submitted with regards to this altered formulation.
Right. So we want to see, I mean, in terms of submission in ANDA, we would like to see all the individual data and plots. And with respect to the altered formulation using the bench batches, which is okay, but we want to see all the composition and the procedure for manufacture of these products, of this altered formulation. That way, we're able to assess whether your formulation is 50% or 150%. Because we've seen in some cases, even in selectivity studies, where people change multiple critical excipients for one altered formulation. So that becomes a little complicated to evaluate because we want to see keeping the strength of the product, but changing one excipient at a time. So all the individual plots and the slopes should be provided to the agency.
Okay, thank you. Let's move to the next slide, which is the selectivity study versus supplemental selectivity. So we heard from Sam earlier today, what is the distinction between these two? And we would like to note that this should be demonstrated by statistical analysis, especially selectivity. I think one thing that we can clarify is the altered formulation for the supplemental selectivity study. So we heard earlier today that we are expected to see some changes in the formulation to be able to have a different release rate compared to whatever you to the reference or test product that is used for the validation studies. So the question I have for the panel, is there any limit in terms of how much change you can introduce in the formulation, like a Q2 change, Q1 change, or even use a different dosage form for demonstration of supplemental selectivity?
My feeling is no. So I appreciate the challenge that that Josephine, that Josephine brought up. But the challenge, on the other hand, is that there are some gels, for example, that you do modest changes to them, and you may not see a difference in the release rate. You almost have to it's not a gel anymore by the time that you're seeing a difference in the release rate. And so the intention here is less a focus on the formulation and more a focus on the IVRT method and the ability of the IVRT method to detect a difference in release rate when it exists. And this is, I think, one of the challenging aspects of the supplemental selectivity. What it adds to the validation is that it now includes a component that shows that even at the same strength, which is the pivotal study condition, that if there are alterations other than strength, which is what you're most worried about in the pivotal study, that there's some difference between your test and reference product at the same strength, that there's some difference that you hope the IVRT method will pick up. The supplemental selectivity adds that, yep, it can do that, but you may have to substantially alter the dosage form in order to be able to create differences that are going to create. It's hard to interpret the results if you make small changes and then you don't see a difference. You can't necessarily interpret that as being a failure of the IVRT because you don't know that difference would have necessarily changed the release rate. Now, when you do the altered strengths, you need to expect it, you need to see it. When you change just the formulation, you don't know how to interpret a failure there. And I think this is one of the challenges in this aspect of the validation. But I think because of those challenges, one needs to accommodate that you may need to change that dosage form quite substantially.
Thank you, Sam. And I also want to mention that sometimes the amount of change that we introduce make the formulation to not necessarily be suitable for that specific IVRT in terms of having the perfect linearity, etc. So if you run a supplemental selectivity, you have a perfect release profile for your test or reference, but not a like a perfect linear release profile for the altered formulation. And that should be acceptable because your IVRT method is developed based on your test and reference product, not based on the altered formulation. Okay. Let's move to the next topic, which is the specificity. So Sam covered it very well in his presentation and clarified on the expectation with regards to the suitable linearity of the drug concentration versus release rates. And if you go to the next slide, we have some examples of the specificity curve and the challenges with establishing selectivity in different situations. So in the first example on the left, this is maybe an ideal situation where our nominal strength 100% is well discriminated from the higher strength and the lower strength. We have sensitivity, we have proportionality in the release rate, and we also, if we run a statistical analysis for selectivity, we can pass it because we see the and these dots are for individual diffusion cell data, the release rate from individual cell data. So they are well discriminated. In the second example, well, the discrimination is less, but still may be acceptable. It's a little bit borderline in terms of overlapping the standard deviation, but we need to run the stats to see if it passed the selectivity. But we also may have a case like the graph on the right, where we still see higher release rate or lower release rate when we increase or decrease the nominal dose amount, but we are not really able to discriminate it in the selectivity study. And we see the slope of the specific curve is very shallow. So while we don't have a requirement of a slope value for a specificity curve, we again invite you or encourage you to observe your data qualitatively, look at it, and you can tell like the method in the right is not discriminative, but the method on the left is very well discriminative.
Yeah, so I'll offer two additional points. I think you said that nicely. And one thing, we've talked about that 0.97 R squared, 0.95 R squared. So the 0.97, I hope is clear. That's when you're looking at the release rate in a diffusion cell, 1, 2, 3, 4, 5, 6 hours. This is when you're looking at the three strands. This is the specificity curve. It's for this that we're looking for 0.95. Okay, that's the first clarification. The second is that when you've got a shallow slope like this, much less discriminating IVRT method, the response in release rate to the same changes, these are the same changes all right? 50, 100, 150, same changes all the way across the board. This response is far less responsive, far less discriminating. What ends up happening, though, is that if you stretch out your points far enough, you take this out to 200, 300, eventually you'll say, hey, I can discriminate it. So there's two ways to approach this. One is that you say, well, it has to be a specific slope. Not a big proponent of forcing people to have a specific slope. Or you say, look, we have a lot of experience to know that 50, 100, and 150 should be discriminated for, within the bounds of 75 to 133. And therefore, as long as you use these and you're able to discriminate these strengths, then it inherently means that you have a suitably discriminating IVRT method. That's essentially the situation we're in, at the moment. And if people feel that there can be some improvements made to that, I'd welcome a discussion on that.